There are two ways of measuring a circle segment, either in degrees or the outer length or radians. Today we explore this new method, which is labelled as Advanced Trigonometry. If we consider the formula of the circumference of a circle, 2 pi r. In this instance, r equals 1, so we can cancel it out. Now we can consider the formula to be 2 pi, which then equals 360 degrees, meaning pi by itself would equal 180. This is the building blocks of radians and degrees. Examples of these could be 30 degrees is equivalent to pi over 6, because 30 is a sixth of 180. 90 degrees would then be pi divided by 2, because 90 is half of 180. And then 270 degrees is equivalent to 3 pi over 2, because 270 is 3 over 2 by 180. If we were to draw these examples, 30 degrees would be theta, and then the length here would be pi over 6. 90 degrees would mean the length over here is pi over 2, and 270 degrees would then equal 3 pi over 2. If we consider 1 radian, and we also know that pi equals 180 degrees, therefore 1 would equal 180 divided by pi, which is more or less equivalent to 57.3 degrees. So therefore 1 radian equals 57.3 degrees. The conventions in higher mathematics are to only use radians. So to convert back and forth, we can use this trusty diagram. Let's go through a few examples. If we consider 120 degrees, when using the formula, we have to use degrees times pi over 180 to convert from degrees to radians. If we then substitute these values in, which would be 120 degrees times pi over 180, which is then equivalent to 120 pi over 180, which simplified equals 4 pi over 5. If we want to convert to degrees, we can use the opposite operation. If we take 5 pi over 9, if we use the formula, we have to say the radians times by 180 over pi. If we substitute these values in, we get 5 pi over 9 times by 180 over pi. If we multiply these together, it becomes 900 pi over 9 pi, which then can be simplified to 100 degrees. If we consider a circle placed on the Cartesian grid, with 0, 0 being the center and the radius being 1, the sine and cosine rule will give you the exact coordinates of any part of the circle. With the coordinate, we can create a right-angled triangle. Using theta, we can identify, using basic trigonometry, that cos theta equals the adjacent over the hypotenuse, and sine theta is equivalent to the opposite over the hypotenuse. If we look at the adjacent length, it would be the length along the x-axis, giving the adjacent for cos as x. Also knowing the radius of the circle is 1, the hypotenuse would equal 1. For sine, the opposite would be this length, the vertical length, or y. Again, the hypotenuse would equal 1, or the radius of the circle. So using this, cos theta is equivalent to x, and sine theta is equivalent to y. With these two formulas, we can figure out the coordinates. Cos being the x, cos theta would then equal x, and sine theta being the y, sine would then become the y. Theta can be measured clockwise or anti-clockwise. If anti-clockwise, it would then be positive, and if clockwise, it would equal negative. If we consider this angle of 335 degrees, it is also equivalent to negative 35 degrees. If we want to find the coordinate, we then use the rule we found earlier. If we supplement this in, it would then equal cos 335 sine 335, or cos negative 35 and sine negative 35. If we then put that into our calculator, it displays cos being 0.9. Another example. Find the possible values of sine theta if cos theta equals 1. If we expand the formula we found earlier of cos theta sine theta with Pythagoras, this could be said that cos theta squared plus sine theta squared equals 1. If we apply what we're doing with this problem, cos theta equals 1, so that's 1 squared plus sine theta, which equals 1. If we simplify this down, to get sine theta squared as a subject, we land up with the 1 squared, which equals 1, going into the other side, and then 1 minus 1, which will then equal 0. So therefore, sine theta is equivalent to 0. If we graph it, we know cos theta equals 1. So therefore, cos theta being the x, we know that it has to be on one of these coordinates. We've now figured out that sine equals 0, so we know that it is here, although we could have figured it out, because the only point that intersects in the circle is where it says sine theta 0. Finally, we look at trigonometric functions. If we were to look at fx equals sine, then it would come up like this. A periodic function. Periodic functions are ones that happen over and over again. The various points to consider in this function is the period, the maximum and minimum point, the amplitude, and the principal axis. The period is the length at which a single cycle starts and finishes. The maximum point is the highest point, and the minimum is the lowest. The amplitude is the amount it raises or decreases, and the principal or mean axis is the line running through the middle or the average of the graphed function. If we looked at the basic sine function, it would have an amplitude of 1 because the maximum and minimum point is 1 or -1. In this function, a period is 360 degrees, as it starts and ends between 360 degrees or 2 radians. The basic cosine rule is basically the same, but a translation of 2 pi units left or quarter of a period. The general sine function is y equals a sine b times by x minus c plus d. A affects the amplitude, B the period, C affects the horizontal translation, and D affects the vertical translation. For example, if we dilate it by 2, it would graph out to create the amplitude as half. If we dilate the period by a half, the period length would double. If we do a horizontal translation of 2, the period or graph would move 2 units back. And if we do a vertical translation, the function would move further up the y-axis. In conclusion, we now know that there are 2 ways to measure a segment in a circle: degrees and radians. And now we also know how to convert between them. We also know that to find any coordinate on a circle, it is cos theta sine theta. And also that cos theta squared plus sine theta squared is equal to 1. And that the sine rule and cosine rule are periodic functions that repeat itself over and over again. And we can adjust it using a basic formula.